On October 4th, 2025, the surface of Mars witnessed something extraordinary. NASA's Perseverance rover, exploring Jezero crater, captured an image that would ignite one of the most fascinating cosmic debates of our time. In the image, a slender, glowing stripe, stretching across the Martian sky, appears like a wound carved into the heavens. Social media erupted overnight. Some called it an artifact of light. Others insisted it was no accident. Many wondered, had Mars just recorded an interstellar visitor? The streak, roughly 4 times longer than it is wide, defied easy explanation. Its symmetry, its sharpness, it's impossible to scale. Within hours, theories flooded online, from camera errors to alien engineering. Yet one name kept surfacing above them all: 3I/Atlas, the interstellar traveler tearing through our solar system. This wasn't the first time humanity had spotted a cosmic outsider. We'd seen Oumuamua, we'd seen Borisov, but 3I/Atlas? It was different. It arrived with speed and purpose, and now it seemed it had been caught on camera from the surface of another world. As debates raged, NASA quietly confirmed the timestamp. Sol 1643, 21 hours 33 minutes and 39 seconds local solar time. The rover's right navigation camera had indeed recorded the image. But what it captured wasn't yet clear. Was this just a glitch in the lens? Or a glimpse into a new chapter of interstellar contact? Something was moving above Mars, and the world wanted answers. At the heart of this mystery lies an object humanity is only beginning to understand: 3I/Atlas, the third confirmed interstellar visitor ever recorded entering our solar system. When Perseverance captured its eerie image, 3I/Atlas was estimated to be 38 million kilometers from Mars, a cosmic wanderer slicing through the darkness between worlds. Astronomers had been tracking it for months, tracing its hyperbolic path as it slingshot past the sun, destined never to return. This wasn't just another comet. It was a messenger from deep space, a fragment of another star's creation, shaped in a realm beyond our own. When news spread that the Mars rover might have seen it, the reaction was immediate. Was this proof that we were watching an alien fragment glide past Mars in real time? Social media exploded with speculation. Some saw a cylindrical silhouette, a needle of light cutting through the Martian sky. Others compared it to an artificial structure, an object not shaped by gravity or chance, but by design. That's when Professor Avi Loeb of Harvard, known for his bold theories on interstellar objects, entered the debate. After being contacted by U.S. Congresswoman Anna Paulina Luna, Loeb analyzed the data and delivered a sobering verdict. His calculations told a different story. Based on the camera's angular resolution 0.33 milliradian per pixel, the streak, if truly 3I/Atlas, would measure nearly 50,000 kilometers long. That's not just unlikely, it's impossible. If true, it would dwarf entire moons. It would rewrite physics. And yet, Loeb insisted reality was simpler and stranger. The mystery, he said, might lie not in the sky, but inside the camera itself. For days, the image divided experts. The stripe was too perfect, too symmetrical, too deliberate. But according to Professor Avi Loeb, the explanation didn't lie in alien engineering. It lay in the science of light itself. Perseverance's right navigation camera, or Navcam, wasn't built to capture fleeting interstellar objects. It was designed to navigate alien terrain, a tool of precision, not of discovery. When the rover took the now famous image, its sensor gathered light over time, not in an instant but over a span of several seconds, perhaps minutes. That process, known as integration, allows faint objects to appear visible. But when something moves across the sky during that exposure, it doesn't appear as a point. It becomes a streak, a ghostly trace of motion frozen in time. Loeb's analysis showed the stripe was far too large to represent the true form of 3I/Atlas. Data from NASA's SPHEREx Observatory places the object size at no more than 46 kilometers in diameter, nearly 1,000 times smaller than the Martian streak's apparent 50,000 kilometer length. That single number shattered every claim of alien construction. But the mystery only deepened. If the image wasn't fake, and 3I/Atlas wasn't 50,000 kilometers long, then what exactly had Perseverance recorded? Loeb proposed a stunningly simple idea. During a long exposure, 3I/Atlas moved, streaking across the frame, leaving behind a bright trail of light, amplified by hundreds of stacked images. In truth, he said, the camera hadn't captured the shape of 3I/Atlas. It had captured its journey. A cosmic fingerprint of motion, not form. To understand the image, one must imagine a cosmic ballet, a delicate choreography between two travelers, Mars and the interstellar wanderer 3I/Atlas. Mars moves around the Sun at 24 kilometers per second, a steady, graceful orbit through the void. But 3I/Atlas? It cuts the sky in retrograde motion, moving in the opposite direction at nearly 67 kilometers per second relative to the Sun. When these two trajectories cross, the result is staggering. A relative velocity of 50,000 kilometers per second, enough to carve a luminous scar across Perseverance's sky within minutes. Loeb's analysis revealed something extraordinary. If the Navcam recorded exposures of just a few seconds, stacking frame after frame over an estimated 10-minute period, that relative speed could easily produce a stripe tens of thousands of kilometers long in the image. Every pixel of that stripe, every faint glimmer, represented a moment in motion 3I/Atlas racing across space, captured not as a body, but as a path. Each individual Navcam frame lasts up to 3.28 seconds, meaning hundreds of exposures could have been layered together, magnifying both brightness and length. The result? A streak that seemed impossible, yet perfectly matched the physics of light and speed. Loeb explained that in a single short exposure, 3I/Atlas would have appeared as no more than a faint point, its movement smearing the image by just a few hundred kilometers. But in a stack of exposures, the motion multiplied, and the sky recorded a silent symphony of movement. It wasn't alien architecture. It was celestial motion painted by time itself. Even with all the data in hand, one question lingered like a shadow. What if the streak wasn't 3I/Atlas at all? Professor Loeb himself raised the possibility that the mysterious stripe might not have been a distant interstellar traveler, but something far closer to home. Something orbiting Mars itself. Mars has two small moons, Phobos and Deimos, remnants of ancient collisions or captured asteroids. Phobos, the larger of the two, measures roughly 22 kilometers across, and as seen from the Martian surface, it's no mirror. It's visible, resolvable, a looming pebble in the pink sky. Loeb calculated that Phobos appears with an angular diameter of 2.4 milliradians, enough to be clearly detected by Perseverance's Navcam. If the camera had taken an extended exposure while Phobos crossed the sky, its rapid motion could smear into a line, a stripe nearly identical to what was seen. In fact, Phobos completes a visible crossing of its own diameter in just 10 seconds. If Perseverance's system stacked multiple exposures during that time, the result would be an elongated beam, a celestial blur resembling the very artifact now stirring debate across the globe. In Loeb's words, one way to think about the stripe is as a sequence of smeared snapshots, like a pod of green beans. It was a humbling reminder. Sometimes, even on Mars, the sky plays tricks on the instruments that watch it. But if the stripe was Phobos, it begged another question. Why did its timing, direction, and trajectory so perfectly align with 3I/Atlas's predicted path? Could coincidence alone explain such precision? Or had Mars, in that fleeting instant, caught a glimpse of two cosmic bodies, one local, one interstellar, crossing paths in silence? For all the speculation, from camera artifacts to Martian moons, one thing remained constant. The world wanted answers. NASA scientists knew that confirmation wouldn't come from speculation, but from data. And somewhere above Mars, aboard the Mars Reconnaissance Orbiter, another set of eyes had been watching, far sharper, far more powerful. The orbiter's HiRISE camera, renowned for its unmatched clarity, had been tracking 3I/Atlas for days. On October 3, 2025, HiRISE captured its highest resolution image yet, resolving details down to 30 kilometers per pixel. The results were still being processed, locked away in NASA's data archives. But everyone knew what those findings could mean. If HiRISE revealed a consistent streak, if the data aligned with Perseverance's, it could validate the theory that Mars itself had photographed an interstellar visitor in motion. If, however, it showed nothing, the stripe might indeed be nothing more than an artifact of time and light. Behind the scenes, tension grew. Astronomers across 7 orbiters, along with Perseverance on the ground, were all focused on a single goal: to understand the truth behind the stripe. Would this turn out to be the first cross-planetary observation of an interstellar body from the surface of another world? Or a reminder of how fragile perception can be when peering into the unknown? NASA officials hinted that the HiRISE results were imminent, and with them, perhaps, the end of a mystery that had captured global imagination. But beyond the data, one truth had already emerged. Our instruments may be human, but our questions are infinite. Each image, each streak, each pixel of light reminds us that even a simple blur on a red planet sky can challenge how we see the cosmos. Every era in science is defined by moments that force us to look up, moments that remind us how small, and yet how capable we truly are. The story of 3I/Atlas is one of those moments. First detected by the Atlas Survey Telescope in Chile on July 1, 2025, this icy traveler arrived unannounced, crossing the boundaries of our solar system like a message written in starlight. I was not born here. It came from the darkness between suns. And when NASA's Perseverance rover captured its faint streak over the skies of Mars, humanity stood witness to something never seen before: an interstellar object observed from another planet. For scientists, the implications were profound. This fleeting glimpse from Jezero crater added a new dimension to our understanding of cosmic motion, light, and observation itself. Each photon collected by Perseverance told a story, not just of 3I/Atlas, but of our own technological reach. It proved that even on a distant world, guided by machines we built, we are still explorers at heart. Yet beyond the data, something deeper resonated. The image, though born of light and time, became a mirror, reflecting our endless hunger to know, to see, to understand what lies beyond the horizon. Whether a camera artifact or a true interstellar trace, the event united astronomers, dreamers, and skeptics under one shared truth: the universe is not done surprising us. As 3I/Atlas fades back into the dark, it leaves behind more than numbers. It leaves a legacy, proof that even in a single streak across a Martian sky, we can glimpse infinity. And for a moment, humanity looked up together,